I hope you're good, enjoying the festive season. Anyways, so now let's start. Um, so first of all, we are covering up chemical equilibrium. Okay. By the way, this is the fifth time I'm making the video. Okay. All right. I hope this is good. Otherwise, I'll be making the sixth time next time. Anyways, so now you see over here, we are making a quick video on chemical equilibrium. Okay. So this equilibrium, the word equilibrium means that the reaction is reversible. Okay. And whenever you see this symbol in a chemical equation, okay, that means it's a reversible reaction. All right. So over here there are certain like conditions that has to be followed and then only then the reaction will be considered to be in the equilibrium state. Okay. So first condition is the rate of forward reaction is equal to the rate of backward reaction. Okay. The second condition is the concentration is constant throughout of the reactant and the product. And then the third one is that the container has to be a closed container. Now, why exactly we have to have a closed container? Because let's just say we are having this reaction in a container, okay? And let's say if there is a hole over here, okay? So what would happen is this carbon dioxide gas, it would escape out, right? And hence this will be then no more um, a reversible reaction because carbon dioxide has escaped, so no more backward reaction can happen, right? Okay. However, let's just say if we didn't have a hole over here and we had a perfect closed container over here, okay, so what would happen is the backward reaction will happen, okay, and like everything will go smoothly, right? Okay, so three conditions, okay? By the way, let's just say if we add a word dynamic to it, okay? Dynamic equilibrium, okay? So let's say if I ask you, it's a two-marker question, okay? What is a dynamic equilibrium? So you have to describe to me dynamic separately and equilibrium separately, okay? So first of all, you'll tell me that dynamic is an ongoing chemical reaction where continuously the reactants are turning into a product and continuously the products are turning into the reactant by breaking down, right? Okay, and equilibrium, we have already talked about these three factors. You write about them, okay? Now, we are talking about uh, effect of different stressors on the equilibrium shift, okay? Now, let's look at this scenario over here. So, if you look over here, okay, wait a minute. Okay. So if you look over here, the forward reaction is endothermic and the backward reaction is exothermic, right? Okay. And if I would increase the temperature, so obviously the endothermic reaction will be favored more, right? That means the reaction will go forward more and backward less. That means it would look something like this. Okay. So you see, reversible reaction is there, but forward is happening more, right? Okay. And as a result, what would happen is the equilibrium would shift forward, okay, and the yield will increase over here, okay. And why is that so? Because the forward reaction is endothermic, okay. You would write about it, okay. I'm not writing, it will take time. So I'm just saying the forward reaction is endothermic, okay, because of which, in fact, wait a minute, I'll write for you. Forward reaction is endothermic, okay, due to which, okay, the forward reaction is favored more, right? What is yield? Yield is the amount of product produced, okay. So equilibrium has shifted forward. Why? Because this reaction is endothermic reaction. Endothermic reactions absorbs heat energy and they would produce more of the product, okay, and all that. I hope you understand it. Now let's say if vice versa it was asked that what would happen if there is decrease in temperature. So obviously then it will be the opposite scenario because we are no more applying heat, okay. We have reduced the temperature, okay, in this scenario. So obviously the backward reaction, exothermic reaction will be favored more and the yield will decrease in this scenario, okay. And the reason you would write that the backward reaction is exothermic reaction, right? Okay, then we are talking about what would happen if we are talking about increase in pressure. Now, first of all, I'll write reason over here, okay? So if we are talking about, wait a minute, let me pick a different color. Okay, yeah. So if we are increasing pressure, okay, so the equilibrium would shift towards the side where there are less gaseous moles. Okay. How would you know that there are less gaseous moles? Because you see, this S over here means solid. This G over here means gas. And if there is L like that, okay, that means it's a liquid, okay? So you will only count the gaseous moles, that's it, okay? So if we look over here at this end over here, okay, so it has one gaseous mole. Why? How do you know that? Because you see, this number before, if nothing is written, that means it's 1, okay, and over here it's 1, right? Okay, we are not considering this because it's solid, but it is gas, we will consider it, so it's 1 over here, although it's 1, but since it's a solid, we will not consider it, and there will be 0 moles over here, right? Okay, so where there are less moles, the less moles are on the backward, right? Okay, so equilibrium would shift backwards, okay, and the yield will decrease in this scenario. Got this, everybody? Okay. Now, one thing more I can ask is that what is the color of the resultant solution, or things like that, okay? So over here, I'll bring up the bromine thing. Okay, so let's just say this kind of question comes up in the exam, okay? All right, and they ask you what is the color, okay? So over here, you have to consider like what kind of a question is this, first of all, okay? Let's say over here, I have told you already, in the question it will be given to you, the color, initial colors, okay? All right, so let's say NO2 is brown and N2O4 is colorless, right? Okay, and let's say in the exam I ask you what would happen if I would increase the temperature, okay? If I would increase the temperature, all right? So the forward reaction is exothermic in this scenario, okay, and the backward reaction is endothermic in this scenario, okay. So obviously the equilibrium would shift backwards, right? Equilibrium would shift backwards, all right. The yield will decrease. The yield will decrease, all right, over here, and as a result, what would happen is the color, if we talk about, it will be more brown. Why? It is more backwards and less forward, right, in this scenario. Now let's talk about the other scenario. Let's say if I'm talking about what would be the effect if I would increase the pressure, okay? If I would increase the pressure, so the reaction will be favored towards the side, or equilibrium will be shifted towards the side where there are less gaseous moles. So if I see over here, there is 2, the bigger number, not this number, okay? This is the number of atoms. We don't count this, okay? The bigger number over here is 2 over here. So this is 2 moles over here, and this is 1 mole over here, okay? So over here, the less gaseous moles are towards the right side or towards forward, okay? So the equilibrium will shift forward or towards the right side, and because of which the yield will increase, okay, and the color will become colorless, or you can say it will become pale brown in color, right? Okay, then we shift back to this page over here where we have to talk about catalyst. Now remember, catalyst will have no effect at all, no matter it's endothermic, exothermic, how many moles, it doesn't matter. Why? Because catalyst would decrease the activation energy, okay, and it would increase the rate of reaction, and it has no effect on equilibrium at all, right, everybody? Okay, I hope you all understand this. This is it about the chemical equilibrium. All the best.